Hi guys, this is Mateo with Build 5, and we're going to explain how the integrated circuit works with the code. One thing that's important to know about the integrated circuit and why you use one is that with only 3 data inputs, it can let out 8 outputs for data. So you have 8 lights here, and instead of hooking one wire to each light, so there'd be 8, you can do it with only 3 to the integrated circuit, and then 8 from the integrated circuit to the lights. So it makes things more efficient. In the code we yes, wait, I'm doing something. These are the 3 types of data the integrated circuit takes in. So we're just calling them and where the pins are, where they're hooked up to. So data, that's where it actually reads the code. Clock is how fast, how much data in a given period of time it'll take in. And latch is kind of your on and off switch of when it will. And then we have, so here in the setup we basically set them all to an output pin mode, and then each 3 to an output. Then you get to your loop. You set up the integer as a constant delay time of 100 milliseconds, and then you have your for loop where it says that start at the integer I equals 0 and then when it gets to 8. So run this till it gets to 8 and add 1 for every integer it goes through. So it changes. So for change LED, that's this function right here that is the code that lets it actually change an LED from on to off. Well, you're setting it on, so it'll actually turn on. And then there's a bit of delay time, that 100 milliseconds, and it runs that back and forth again for 8 times. Then it gets to the second part, which is the second for loop, and what it's gonna do is go to that condition of 8. But the only difference is then it'll change LED from on to off. So each of them turn off. Integer bits, that's basically, if you know, 1 byte has 8 bits, so each LED has its own assigned what bit it takes, how it recognizes it. And so each one there's 8 different numbers, and then this first one's 1, and then here the second number's 1, and kind of goes in that pattern. And masks is basically the exact opposite way. And here's the function for change LED. Basically LED state, where it says it equals the LED state, and the masks, remember that variable right here. Well, it clears LED state of the bit that we're addressing, and then this if statement says that if state equals on, then LED state equals LED state. So basically, if the bit is on, then we'll add it to the LED state. And then this last thing, well, it basically update LEDs and then put in LED state. It sends the new LED state to the shift register. So then you can just plug that function right here and assign it just these 2 parameters for it to work. And that's basically how it works. Hey, Doug.
Really? Sorry. It's just about done, dude.